Friends, welcome to the lecture series on Industrial Automation and Control, course code KEE 053. So today we are going to study basically the different components of a PLC. So as you can see on the screen, these are the major components of a PLC. Now if I were to compare the PLC with human body, so in human body that we have got mainly the different sensory organs. So you have your you have your eyes to see, you have your ears to hear, you have your nose to smell, you have your hands to touch, isn't it? So all these sensory organs, these are giving the different inputs, these are providing the different inputs to the brain, and the brain is responding to these inputs. So similarly in a PLC we can say that we have a processor which is called the brain of PLC, and in this particular processor we are providing the different inputs through different sensors. Now these sensors can be push buttons, these sensors can be limit switches, it depends upon which type of sensor you are using. So all the sensors they are providing the inputs to the input module. So from the input module these inputs are going to the processor, which is the brain. So the brain of the PLC, because it is the processor where you are having the program, so depending upon the conditions that you have created in the program, your processor is running that program and giving you desired outputs, which is being given to the output module, and to this output module you can see n number of actuators are connected, contactors, relays, solenoids. So you can say that the processor is acting as a link between the input module and the output module, and of course the processor requires some power to run, which we are providing from the power supply which we are using, that is SMPS. This is the power supply which we are using. S means switch mode power supply. We are using pure DC here, we are not using pulsating DC, means whatever DC we are getting from the power supply is pure DC. And of course we have a programming device here, as you can see, it can either be a laptop, it can either be a desktop. So whatever software you are having, means the programming device will have the software will depend on the make of PLC. Okay, for example, if I say to you that if I were to compare here, if I see we are having this PLC which is of make Delta. So Delta is going to have its own dedicated software which will be basically there in your PC, and where you will be developing the different programs. So that those programs you are going to feed into the PLC memory. So every PLC will have a memory. Now here you can see here the power supply for the CPU. This is the power supply, switch mode power supply, which we are using here. It is 230/24 volt DC. 2.5 ampere is the ampere rating of the power supply, and make of the power supply is Meanwell. So if you compare it here, if you compare this block diagram with this diagram, you will find out that we are having a CPU which is inside, because this is a medium sized PLC. It is not a small size PLC, because it is having a dedicated power supply, separate power supply for itself. Okay, so here are the different sensors you can see which we have used. NBN type proximity sensor is there. These are the push buttons, as I told you earlier, which are basically providing inputs to the input module. So this is the input module of the PLC. This is the input module. Okay, this is the input module of PLC, and this part here is the output module. So input module is used for connecting all the different sensors to the PLC, as you can see here. Clear? Now moving further, we have features of small size PLC. See, PLCs are of different categories available in the market. We have small size, we have medium size, we have large size. So if we compare the PLC, if we look at the features of a small size PLC, so we have different makes are available in the market, like Siemens is there, Schneider is there, Allen Bradley is there. So these are used in simple machines or applications with small IO counts. Building automation, car park lighting, extra. Means you are using these small size PLCs, means you are able to program them on the the buttons. These are the buttons which are used for programming the PLC. Means you don't require to connect any extra laptop or desktop with this PLC. Okay, you don't require any communication cable. You can itself program it through these buttons. This is a small size PLC. In medium size, you will have one communication cable. See, so you supply power to this PLC and you are good to go. Then CPU communication ports and inputs and output ports are all built in. CPU and communication all is inside the PLC. Additional communication ports and input outputs can be added as separate modules. So you can add additional communication ports as separate modules in this PLC. If you look at some can be programmed directly by small buttons on the PLC itself. So certain small PLCs you can program by the help of buttons on the PLC itself. Second type, if we see features of medium size PLC, examples are S7 1200 by Siemens, M340 by Schneider, Compact Logics by Allen Bradley. All these are medium sized. They are used in the factory automation or process automation industry, and also less critical subsystems in plants using DCS for their main control. So normally factory automation will have such type of PLC. And power supply is normally a separate module from the CPU module. So this PLC which we have shown here, it's a medium size PLC because power supply is a separate module here. SNPS is separate, it is not inbuilt, it is not inside the PLC. Okay, then we see here may have a backplane where all other modules plug onto it. Backplane provides the bus and bus power, and also the possibility for removal and insertion of modules under power without powering of the system. Backplane means if you want to extend, let's say if you want to extend the input output modules, input output modules, so you have that facility. Extend means if you are adding, let's say, more number of sensors in your field system, okay, and you want to increase the input output list of your PLC. Input output list means you are increasing the number of sensors, you are connecting more sensors on the PLC. So instead of purchasing a new PLC, you can add basically extra modules to the PLC. So that is known as backplane. It says backplane provides the bus and bus power and also the possibility for removal and insertion of modules under power without powering of the system. Then we have a software is not free of this PLC. It will cost you something around 2 to 5k US dollars. Okay. Then it consists of 5 IC programming languages, mainly ladder, functional body diagram, structures, test, instruction list and sequential chart. All must be programmed by a PC or laptop. So it is very necessary for medium sized PLC. And then we have the features of full blown PLC systems. Examples are S7 1500 by Siemens, Quantum by Schneider and Control, Logix 5 by Allen Bradley. Has all the functions of medium PLC bus. So these are used for large plants or for functional critical applications. Means where we require, where you have got, let's say in a steel plant, you have got these 6HI cold rolling mills are there. Okay, where you have got, where you convert, hot rolled sheets into cold rolled sheets. So hot rolled sheets are converted into cold rolled sheets. What happens here? Here you have got a lot of functions are there in the machine. Means there are a lot of interlocks in the machine, and the input output list is also very big. Input output list is very big. So for that purpose, where you have got a large number of digital inputs and a large number of digital outputs associated with a PLC, there you have got full blown PLC systems. So where you have large plants, they are used in those applications. They almost always have a backplane, because at any point of time when you are expanding the system, you can add those extra modules with the existing systems instead of replacing the existing system. So there is redundancy, means you can add new system with the existing system. You can interface extra modules with the existing system so that you can meet your expansion plans. So ability to perform almost whatever a DCS controller is able to do. DCS stands for distributed control system. Distributed control system. So in the next lecture we are going to study about the automation pyramid. Till then, keep liking the channel and happy learning. Thank you.